will be on.
All right. Hello, folks, and welcome to another edition of The Binding Status. This is your host, Dan. I am here every other week for our episodes, unless we do an off week like last week. And I want to welcome all of those joining in the chat today. Two of our hosts today, Carlisia and Nolan, have mentioned that they're here today, joining from San Diego and North Central Indiana. Specifically, we also have Jared, also joining from San Diego. He's one of the founders of the Crossplane project, and Mocha, who runs our live tweets, joining from San Francisco. So as you folks join the stream, please feel free to introduce yourselves in the chat, and we'll make sure to circle back around and see if there's any questions, and also give shout outs. Speaking of that, Jonas, who is a community manager from the Velero project and some other VMware projects, joining from Boston. And it looks like Rahul is also joining. So thanks to all of y'all for joining. Before I do the introductions of our awesome co-hosts today, I wanted to, on a personal note, as we like to keep things personal and have some human interaction in this show, wanted to encourage anyone who's joining from St. Louis, Missouri, where I am, to consider donating today. Today is St. Louis Gives Day. So if you go to stlgiveday.org, you can give to all different kinds of organizations and nonprofits in the area. A lot of them are needing some extra donations right now in these tough times. So I'd really encourage you to do that if you have the means to do so. And thank you to St. Louis Gives for making that opportunity available. So now I want to go on to introducing our co-host today, which is always the highlight of our show. We have Carlisia and Nolan on. They're both from the Valero project, both work at VMware, and they have been gracious enough to spend some time with us today. And I am super excited about it, both folks that I look up to in the cloud native community. So Carlisia, I'll let you start off and just give an introduction for yourself and talk about anything that's on your mind today.
All right, introductions are hard. I never know which one to give because I have like 10 different ones. I lived in Boston for a long time. I'm saying this because I was reminded of Boston because Jonas is on the call, is on the chat too. And I moved to San Diego 12 years ago. No, 8 years ago, something 8 years, less than 10 years. And I've worked at Fastly. I went to school in Boston, have a CS degree. I worked at Fastly. And after Fastly, I've worked at a bunch of places, but just like most recently worked at Hep2, and that's how I came to VMware through the Hep2 acquisition. I always worked on the Velero project, which is amazing. We are so open to having people contribute, so check us out. We'll guide you. And I am currently working on I'm developing a brand new controller, and it's super cool. I'm having fun with that.
Awesome. Well, we'll stay tuned for that. That sounds exciting. And we really appreciate you joining today, Carlisia. One thing I wanted to mention before we get started is, speaking of live streams and podcasts and that sort of thing, Carlisia is frequently on a podcast called The Podlets, which I really enjoy. It's weekly conversations about cloud native stuff. Did you want to mention anything about that, Carlisia?
Absolutely. I can't believe I forgot. Yes. So I started a podcast that is sponsored by VMware, and it's to talk about cloud native concepts, or distributed systems concepts, and how they fit into the new cloud native worlds. And I had that idea because when I came into the cloud native technologies, I was like, what? How does it map to everything that I knew before? So that's the idea for the show. And we've been doing it for over a year. There are 7 hosts, and occasionally we have guests. So that's another thing. If you would like to come on the show, and you have to come with an episode idea, and we can help you and develop more and talk about it on the air. It's not live.
Awesome. Well, yeah, I really appreciate the way that y'all put that together and you share knowledge with the community, especially beginner-friendly stuff. So that's really cool. And we kind of try to have that same mission on this show. So I think we're aligned really well there. And so moving on to Nolan. Nolan is also a engineer and maintainer on the Velero project and does some great work there. He actually just fixed something that I mentioned in an issue. So he's very responsive, I can attest to. But Nolan, do you want to give a bit of an introduction and talk about some of the things you're interested in as well?
Sure, and thank you for that. So yeah, I am on the Valero project as well. Like you said, I came to VMware through Heptio. Before that, I was at Rackspace working on OpenStack Ansible. Before that, I was doing some web stuff, and then got interested in ops and how we could have made our developers' lives easier on working with config management, and at the time, I'm forgetting it, Vagrant, and that kind of stuff. And that kind of led me down this road towards this cloud native space. So yeah, in the Velero project, most recently, I've been doing a lot of stuff with CSI along with Ashish, who's also on our team, the latest member on our team, getting ready to release version 1.4, which hopefully we were hoping to get a beta out by tomorrow. We'll see if that happens. And we'll introduce beta support for CSI. And yeah, some bug fixes for CRDs, CRD backup and restore, and a bunch of other cool stuff with it. So yeah, thanks for having me on the show.
Yeah, absolutely. Well, I appreciate those introductions from y'all. And it looks like we've had one more person join the chat here, Steven, joining from Florida. He also does some work on the Crossplane project. Thanks for joining. All right, so as we normally do, a lot of folks who join the call have seen a previous episode and are familiar with Crossplane. So we like to start off with doing an introduction for the guests that we have on and looking at the project they work on. And specifically, this is an exciting episode today because we did some work on the Crossplane side to support using Velero to back up and restore all of our resources, which then gives you the opportunity to kind of back up and migrate your cloud infrastructure across different Kubernetes clusters without interrupting service and that sort of thing. So we'll show that later on in some of the demos. But for now, I'm going to go ahead and start sharing my screen here. And we can take a look at the Velero documentation. And that is my IDE, not the Velero documentation. Here we go. So now I have it up and we will kind of go through it. And I've been through it a little bit myself. Obviously, Nolan and Carlisia are way more familiar with it than I am and know a lot about the concepts behind it and have built a lot of it themselves. So I will be periodically asking them questions about what we're looking at and kind of giving background on some of the stuff. So the first thing we always start out with is, what would you say in your own words the mission of the project is here? We have, really big, the main functionality, backup and migrate Kubernetes resources and persistent volumes. Is there any other kind of like tangential missions that you see? And what's kind of the motivation for wanting to support this use case that motivated the project getting started in the first place? And either one of you can take that question.
I think it'll be nice to hear from Nolan on this as well. Nolan started out way before I did. My understanding of the origin of the project was that simply there was nothing that did this. And backup is such an important feature of any system. And a lot of people, from my understanding is a lot of people a lot of people don't do backup, sadly. A lot of people maintain their own script, which then makes it hard to do backup and restores if you have to do such a high maintenance on your personal script to get that working. And the idea behind Velero, I think, from what I know of Velero today, is just to make it so simple that there is no excuse for you not to do backups. It's really easy to use.
Definitely. Nolan, did you want to add anything to that?
Yeah, and so there's also like this concept of GitOps. So you can say, well, why do I need backup if all my Kubernetes metadata is sitting in my Git repo and I just reapply it? Well, your GitOps repo doesn't contain everything that's in your persistent volumes. So if you store anything on your file systems, like you've got databases and stuff in there, that's not in your Git repo. So I wasn't there when this came up, but Steve Chris, our technical lead, was sitting next to Joe, and they were working on something, and Joe apparently wanted to make a new cluster based on a cluster that he had, and he wanted to use an EBS snapshot. And he's like, "Hey, there's nothing that does this." The project started as something called EBS Snapshotter, and so it became Heptio Arc and now Velero. And a core thing was, hey, let's get our persistent volume data moving too. But I think it's also useful, whether you use Velero or GitOps, to kind of have this mindset of treating not just your individual pods as cattle, but like your whole clusters as cattle. So let's say a Kubernetes upgrade comes out. Kubernetes moves at a really fast cycle. On a really fast cycle, 3 months is super fast for your infrastructure. So using something like Velero to instead of upgrading your clusters in place, but to lift your application workload, and Crossplane could help with this too, or Cluster API. You use those tools to take your data and your workloads and move them to a new cluster, provision them, and then use Velero to lift them to a new cluster that's got the new version running. I think that's a great use case for Velero. That's not just the backup. Like the backup is, okay, what if my data center and my provider burned down? But there's also the upgrade and migration case to say, okay, Kubernetes is moving really fast. Can I use this to keep up versus just upgrading in place and spinning up new nodes? Can I just make a new cluster, move everything over, and then throw that old one away when I know it works?
Definitely. Yeah, I think that's a really great summary. And as also, operators and projects that are based around adding new CRDs and controllers and that sort of thing, kind of as the Kubernetes extensibility story has exploded, this becomes even more important, right? Because you have a lot more objects doing a lot more things, and then controllers acting on those, potentially creating new objects that are, maybe not even something that you're actively managing yourself. They're kind of state stores for the controller. So as we continue to see more and more projects being introduced into the Kubernetes ecosystem, I think that story gets even more important.
Yeah, when you have CRDs that are acting as state store for the controllers, those make GitOps harder because that state is not reflected in the Git repo. Those are changing in your cluster, and so that's hard. Like, are you going to have those commit to the Git repo every time they change? Probably not.
Right. Yeah, that's specifically an area in Crossplane where we see that, and we'll see that later on in the demos today, is that a lot of cloud providers or infrastructure providers, when you provision a resource, the name is not deterministic, right? So they'll assign you an ID or something like that, and we have to propagate that back to the CRD or the CR for the CRD that identifies that resource on a cloud provider. And then to be able to reassume control of it, we need to have that information when we restore a cluster. So if if you just create that resource again, it's going to go provision a new one because it's not knowledgeable of the existing one. So that's a great example of what you're talking about. You also mentioned, both of you mentioned actually, that this project used to be, it sounded like EBS Snapshotter and then Heptio Arc. Do you all have context around kind of how the project evolved from those different stages to getting to what is now Velero?
So from EBS Snapshotter, I think that was just to make it a more holistic kind of tool. from EBS snapshotter to Heptio Arc was more like a productization. The EBS snapshotter was like, hey, how do we do this? And then to Heptio Arc, from EBS snapshotter to Heptio Arc was like taking it and saying, okay, how do we make this actually useful? So point it at a namespace and say, give me everything in there. And part of that is like, well, it's not really useful to just say, give me the volumes. Like what people use is stuff like deployments and stateful sets and things like that. So you pointed at those things and Velero figures out where the volumes are for you. Heptio Arc to Velero was really just a name change because the Heptio name went away. That was more of a branding consideration. There wasn't really any core changes to the product that happened or project that happened there. And that was part of the acquisition.
Awesome. Cool. So let's move into actually what Velero does, what's happening behind the scenes. The two areas that I want to focus on to start are the backup and restore. So these are easy to conceptualize as they have, they're represented by CRDs in your cluster, which we'll again see later. Can you, either one of you, give kind of like an overview of what happens when a backup object is created in a cluster, and also what happens when the restore object is created?
You can go ahead, Nolan.
You want me? Okay. So I think I'm trying to remember what part of the docs this is in. I think it's in how Velero works.
Gotcha.
But essentially, both for yeah. So for basically everything that Velero does, we rely on the Kubernetes API server. So we don't have our own service exposing anything outside the cluster or anything like that. Our Velero CLI does this. You can make your own custom resource objects doing this. You create a backup, submit it to the Kubernetes API, and it will get created with a status of new, and it just kind of sits there in the Kubernetes API server and etcd by extension. And the backup controller is sitting there watching for those. And when it sees a new one, it's going to process that based on the spec, which contains things like what namespaces are included or excluded, what labels are included, what resource types. So that would include what CRDs, what API groups, that kind of thing. Whether or not the snapshot volumes, that information, that would go to the backup controller and say, okay, I'm going to go ask the API server rather than etcd. It does not back up etcd directly because that does not work with managed solutions.
Mm-hmm.
Unfortunately, it doesn't give you a completely idempotent backup. Like it doesn't, or sorry, not idempotent, but a complete quiescent view of the data, but it does mean that this works anywhere you can get Kubernetes running without any special privileges to etcd. Runs all of that, takes snapshots with the plugins, gathers all that data into, gathers Kubernetes metadata into a tarball, gathers snapshot data into a parallel JSON file, and uploads all that into cloud storage, S3 or some other object storage right now. And there's a time to live. So by default, they expire in 30 days. And yeah, so once all that's gathered, it goes and sits in object storage, which is the Valero's source of truth, because that lives longer than any individual cluster. And then on the restore side, we don't have any associated graphs in here for that, but it's kind of similar. You submit a restore custom resource to the API server. The store controller sees it and says, okay, is this for a backup or for a schedule? So if you're creating a restore from a schedule, it will grab the latest backup made from that schedule. It will go download the tarball for that backup. And if you've got any, again, any includes, excludes, whatever things you want to pull out of that backup, it will try to restore them into the Kubernetes API server, passing them through any plugins that are relevant, cleaning up the statuses and metadata, sending them to the API server with a create method, submitting any snapshots to the storage platform. So it will say create volumes from these snapshots. And then once all that is finished, it will update the status on the restore with any errors and provide logs, which will get stored in the object storage as well. And that's kind of a very high level flow.
Definitely. Yeah. I think you touched on something that I really wanted to focus on there is that, Velero is following a controller pattern to actually back up your clusters as well. So as you'll see in lots of projects, it's reacting to the creation of a manifest that you've created for a custom resource that it defines. It's taking the information you provide on that custom resource and it's taking action based on that. So following the typical Kubernetes controller pattern, I think you made a really good point about not talking directly to etcd as well. We've run into that as well with doing some different things where we're trying to get a little more information or circumvent the Kubernetes API server. But when you are on a managed offering like that, they're just not giving you blanket access to the etcd server. But because all these projects standardize on a common way to communicate, that being the Kubernetes API, we're able to do things like restore objects for lots of different projects because they all are using this same API server and have a common language to interact. So yeah, I think that was a great overview. And I think this diagram here specifically is a nice, simple view of what's happening. It's actually a pretty good view of any Kubernetes controller that you're looking at where it's doing something similar. You could imagine this with Crossplane as well, where we have a controller watching and talking once again to a cloud provider where we're actually provisioning things on that cloud provider. You're instead uploading tarball, for instance, in this case. Before I move on, Carlisia, I wanted to give you a moment if you wanted to add anything onto that.
Yeah, one thing to notice is that might not be obvious is that the storage that Velero uses, it can be anywhere. It can be in the origin, what I would call origin cluster, or in the target cluster, or even outside any cluster at all. So Velero will get the information to connect to that storage space, and that's all it needs. It can be, for example, if you have an on-prem cluster, you can use Minio storage, for example, or any S3 compatible storage.
Yeah, that's an awesome point. And I love one of the things, like right when you install Velero, if you have backups, for instance, in S3 buckets, what we're going to use today, you immediately get access to that. So I've actually used this for development on my own end, where I just want to snapshot a cluster state and be able to easily get back to that without having to, run 6 or 7 commands to install the necessary controllers and CRDs and that sort of thing. So yeah, it really simplifies that. There's a lot of use cases outside just the traditional backup scenario. We've actually, I've backed up things to an S3 bucket and shared them with other folks that I'm working with and allowed them to kind of restore my state into their cluster, into like a fresh kind cluster or something like that. So lots of really cool use cases there for sure. The other thing that I wanted to touch on here in the documentation is you'll see immediately that one of the things you do after installing or as part of the installation process is select a provider. So providers, from what I understand, are kind of a subset of the plugins that you can enable. So if we actually look at the plugin overview, we'll see here that there, or somewhere on here, I think it's in custom plugins maybe, that we have these 4 different plugin kinds, right? Object store, volume, snapshotter, backup item action, and restore item action. So object store is kind of generally what you think of. So like an S3 bucket, where we're doing those backups of Kubernetes resources to them. And then volume snapshotter is more on the persistent volume side, which we're not going to get in too much today, but I'm going to give Nolan an opportunity to talk about that a little bit later. And then there's also these backup item actions and restore item actions that are customizing the way you actually execute those backups and restore operations. So do y'all just kind of want to give me a little more insight into who kind of creates these different plugins, what the difference is between a provider and other types of plugins, as well as some of the ones that are currently supported by Velero?
So originally, to answer the question, who creates these plugins? Anybody can create a plugin if they don't find an existing one that works for them. And we have actually an example repo, should be listed somewhere, that people can look at, or they can look at an existing plugin as well. The reason for the plugin is that a plugin will be necessary to connect to any provider or any anything that you're going to be backing up. So for example, if you use AWS, then you're going to need a plugin that's specific for AWS, because the way the Velero works is, especially for snapshot, well, particularly for snapshotting volumes, Velero, the Velero plugin will use the API of the provider. So that's why everything is compartmentalized in a separate plugin per provider. And you can have, if you have those, you can have all of those different types of plugins in one actual plugin, which is confusing. Is it one plugin or is it multiple plugins? But I hope I made that clear. Mm-hmm. So sometimes one plugin will have all of those different object types, all the different plugin types. At any case, going back to the Amazon example, when Velero started out, we wanted to make sure that we had some plugins for people to use. So the Velero team has developed, and we continue to support the plugins for Azure, AWS, and Google Clouds, Google Cloud Platform. Now, if you go back to the documentation, I don't know if you showed it already because I wasn't looking. At the very top of the documentation page, yeah, there is a plugins. Yes, so that will list all of the plugins that we know of.
Awesome.
And it's tagged, the ones that are supported by the Velero team, it's tagged as such. And then there's a bunch of others that the community has developed.
Awesome. Yeah, this is really interesting because it's very similar to the way Crossplane is structured as well. It's really important, as you mentioned, that you take an attitude of saying, these are the ones that we think people are commonly going to want to use. So we want to, from the get-go, when people are using this tool, enable this functionality, but we also don't want to rule out using anything else. So we each follow a common pattern with our providers, actually called providers as well, where we're talking to the cloud provider and doing things like specific calls to that API to be able to do operations on that cloud provider. We also started off with supporting AWS, GCP, and Azure, and we've seen that grow a little bit. We now support Alibaba, which I see here as well for y'all, and there's some folks from Alibaba doing some of that work, which we really appreciate. And then there's other providers like Packet and that sort of thing, but it seems like a very similar approach. And it's nice when you see that when you come to a project from an end user, because you know you're not going to be locked in, right? If you ever want to move to a different provider or change functionality, specifically with Velero, this is really nice because it's not just that you can alter the backing storage for your backups and restores, but you can also actually modify the behavior. So just one of y'all want to talk a little bit about what the plugins for backup item actions and restore item actions look like, and how those kind of differ from how these providers work here.
Go ahead, Nolan, you take that one.
Yeah, I can take that. So backup item action and restore item action, kind of those key off of so Velero, I guess I'll back up a little bit. Velero has this concept in the code of a Valero selector. So I forget the exact name of the Go type, but it's basically what Velero uses to say, are you selecting a namespace? Are you selecting a Kubernetes API group type, that kind of thing. And most often what we see inside the plugins right now is we apply a backup item action or a restore item action to a type. So we apply this particular backup item action to a pod, for example, or to pods. So it's a way for us to kind of break out the code. And so internally for Velero, I'll give an example. We use a backup item action for plugin for pods. And instead of putting this logic in the main Velero code base, we can put it in the pod plugin, and it will run and say, okay, does this pod have any PVCs attached to it? Yes, go add those to the backup. So in the interface, it lets you do a couple things. It lets you modify the object being backed up or restored, really. The interface is very, very similar for both backup and restore. It lets you modify the object being worked on. It lets you restore or return additional items. So you can say, because this item's being processed, we need to work on some additional items. So this chain of plugins is actually how we say, well, because you're backing up this pod, you need the PVCs and the PVs attached to it, because without those, that's useless to back up the pod. And we can also, thanks to some contributors, we also can return a flag. I can't remember if it's a flag or if we just return nil for the object. But we can say, don't back up or restore this object. So the plugin can help us with a decision to say, actually, because this, and this, don't back up or restore this thing. So I know OpenShift actually, with their Conveyor, I think is the project name now. It used to be Fuser, but now it's called Conveyor. They use this for a lot of their CRDs. So, and like their image stream and stuff like that. So they use that to determine how they're going to restore those objects. So it's really a way for us, the Velero team, to kind of keep our code well isolated and well contained. And then it's a way for folks like the OpenShift team, Crossplane, and whoever else. I know teams inside of VMware are using it. It's for folks to extend Velero and say, well, I know my custom resource needs to do this on restore. It gives them an escape hatch to modify that and extend Velero.
Definitely. Yeah. And that was, I think you actually commented on an issue on our repo when we were working on enabling this functionality in Crossplane about this plugin opportunity. And we looked at that actually for some of our use cases. We opted just modifying our architecture slightly because we realized it was going to be pretty easy to enable this backup and restore in kind of a more native fashion. But that is really cool that you can, modify that. And I could definitely see down the line as we continue to have more complex scenarios, which inevitably evolve when folks are provisioning infrastructure across lots of different cloud providers, developing plugins to handle some of those edge cases. So it's exciting to, we can say to users right now, we encourage you using Velero. And if in the future it's not going to meet our use cases, we'll just extend it to make it compatible. So that's definitely a comforting thing from a maintainer perspective, saying, we are confident that we will make this work for the long term. So it's exciting to see that. We do have a few more things we want to talk about specific to Velero, but we're already about halfway through. So I'm going to start actually the first demo, and it's going to take a little bit for infrastructure to provision. And during that time, we can circle back to some of these things. Specifically, I want to give Nolan an opportunity to talk about persistent volumes and backing up volume snapshots and that sort of thing. But as I said, I want to go ahead and start the demo a little bit. So we're going to use a local kind cluster. If you haven't used kind before, it's just a way to run a Kubernetes cluster in Docker. It's my favorite way to do local development. So we're going to be doing all of that from the control plane perspective, where we have Crossplane and Velero running in a kind cluster. And I have some specific configuration that I'm going to use for this one, but this will all be available in the TBS repo. Like all of our demos are, you can run any of these afterwards, and we'll have guides and manifests for you to do that. So I'll start off with getting my kind cluster running here. Taking a look, we're going to have two different demos today. The first one is going to be a more simple or a more focused example of backing up infrastructure. So we're going to provision a Cloud SQL instance on GCP, and then we are going to make a backup of it with Velero. We're then going to tear down our kind cluster and start a new one, and then restore it back to Velero. So this is a little bit, there's a lot happening behind the scenes. That's not just recreating these custom resources. We have to reinstall the CRDs that represent the ability to create these custom resources. We also have to restart the controllers. They're going to pick up these custom resources and talk to GCP. This is specifically interesting with external infrastructure, because when we destroy the cluster, the external infrastructure is actually not getting deleted. It's still running, even though we are not controlling it actively from Crossplane. So what we do when we reestablish these resources in a Kubernetes cluster, we want to assume control of those resources again. And while they've been running, hopefully successfully, while we've been away, we want to pick up management again. If anything's gotten out of sync, then we will correct it at that point. So now that my kind cluster is up and running, I'll install Crossplane here. So we're using the latest version from the alpha channel. And you'll see I'm actually specifying with flags that I want to go ahead and install the GCP provider alongside that, which is going to enable us to create GCP resources. So if we take a look at the CRDs that are currently in the cluster, we don't have any. After we install Crossplane here, we should see quite a few that are present, including one specific to GCP. All right, so it looks like our Helm chart was installed successfully. So we should see the pods coming up here. For folks that are not familiar with Crossplane, I'll give a quick rundown of the pods that are getting spun up. So we have core Crossplane, which manages provisioning things to clusters that we provision in Crossplane. It also manages some of the claims and that sort of thing, and also our new composition functionality that allows you to kind of group manage resources, which are one-to-one representation of external cloud provider infrastructure together, and provision them as a group and claim them as a single unit. We also have the stack manager, which is basically how we install new providers into Crossplane. It's pretty similar to just installing them as controllers, but what we do in the stack manager is basically make sure that a provider isn't going to come in with extra permissions and do something malicious in your cluster, or run as root in the container, or do things like stomp on existing CRDs and ruin any of your state. So you'll see here that we have the Crossplane controller, Crossplane stack manager, and now provider GCP controller running as well. If we look at the CRDs that are now present in our cluster, we can see there's quite a few here. Some of these are directly from Crossplane, and some of them came along with our GCP installation. Let's specifically look at some of the GCP ones here. And what you'll see is that these represent common resources on GCP. So you'll see things like a Cloud SQL instance, a GKE cluster, some networking resources, and that sort of thing. As I mentioned, we are going to dynamically provision a Cloud SQL instance for this demo. So when we dynamically provision, we start by creating a Cloud SQL instance class, which I will show here quickly. So a class is different from a managed resource in that its creation does not actually lead to the creation of an external resource. It just says this is a template that we want to use in the future to provision resources. So we can create all kinds of Cloud SQL instance classes or classes for other resource types in our cluster. And then later on, when we create an abstract claim for a Postgres database, it will match to that cluster based on the labels that we select. So that allows an organization to basically define their own schema for how they want to satisfy claims for infrastructure. Here we're using a pretty simple label, app TBS, you'll see that this is on the Cloud SQL Instance class. It's also the only class that is going to be in our cluster right now. But you could imagine that you may have a, Postgres large label or something like that and schedule based on those labels. Before we do that, we do need to set up our GCP credentials, which are going to allow us to authenticate in the controller to the GCP API. We have documentation on how to get your credentials for GCP on the Crossplane website, which I link in the guide. I actually have a script here that I'm going to run to just do that for me, so we don't waste time doing that. And before we go ahead and create that resource, I want to install Velero. Here you'll see I'm using the Valero CLI, which this is something I want to touch on in just a moment about kind of the decision to abstract things in the Velero CLI. So we mentioned that this is all based on the Kubernetes API, so we can create these backup resources directly in the cluster if we wanted to, but the Velero CLI makes that a lot easier for us and abstracts some of that away for us. It also makes installing a bit easier. So here you're seeing we're installing with provider AWS, and I've specified a bucket location and the name of the bucket that we're going to use. I have also gotten my AWS credentials, and I'm going to pass those as the secret file argument to the Velero install command. So once I install this, I want to give Carlisia and Nolan both an opportunity to kind of comment on what's happening behind the scenes here. We see a lot of different output. And if we take a look at the pods, we should see that a Velero pod is coming up here. Does one of y'all want to kind of talk about all the things that happen when you run a Velero install with a specific provider?
I'm going to take a stab at that.
Cool.
So as you see there, all of the CRDs that Velero needs, they are all loaded up front. Even if we're not creating, for example, we're not necessarily creating a backup instance of that CRD. I'm just saying all the CRDs get loaded. Mm-hmm. And we check during when we boot up the server, we check that they have been loaded, because we don't want to find that out later. So it installs. So Velero gets the Velero image gets deployed as a Kubernetes deploy, and that runs on a pod. Of course, you can have multiple instances of that. And what else? So the Velero pod will contain the Velero image. So basically, if you don't specify an image, there's a flag that lets you specify the Velero image if you want to get an older version or a local your own version. We do also in the documentation have instructions for how to do your own development. At any rate, so you have an opportunity to specify an image, and if you don't, it will get the latest release. Excuse me, so the cluster will just pull that down. And you do have to specify which, with the installed as it is, you do have to specify at least one plugin. So you specify the provider, and you specify, you give the image, the repository an image. And so that also gets added to the Velero deployment. So when Velero runs, it's going to use all of that code. What else? When you do the install, you also have to pass the information for the storage. Mm-hmm. I'm failing to remember if that's optional, if you can do it later, but the server will fail if you don't do that. I don't know. I don't remember if it's optional. At any rate, you do have to set that up front. Mm-hmm. So you need to also have at least one. And if you don't give it a name, you'll be named default, and that will be the default storage. So if you do Velero create backup and you don't specify storage, we call it a backup location storage. You would use the default. And if you have multiple, every time you create a backup, you can specify which one you want to use, which storage backend you want to use. What else? What else, Nolan?
One thing I wanted to mention Oh, sorry to interrupt you, Nolan, but just to kind of show one thing here in the logs, you can see that I had some backups already present in this bucket. So Carlisia mentioned that they install the CRDs for us, which allows us to create backups and that sort of thing. If we also look at the backups in the Velero namespace here, it's going to go ahead and list those for me that it pulled from the bucket that were already existing. So as soon as you install that provider with a bucket, if you have backups present there, which is kind of how I was mentioning earlier, sharing backups with other coworkers I have that have access to that bucket, they get those right out of the box and they can restore from those.
Yeah, we have a controller that's named Backup Sync Controller. So as soon as you install Velero, and at any time, if it's in that at the moment in time of installation, or if you create it later with the Valero CLI, that sync controller is going to go through all of the backup locations that you have configured and pull from them. And so if you do get backups, you will see it.
Definitely. Sorry for interrupting you there, Nolan. I'll let you go ahead and take the stage here.
Yeah, just one quick thing. The Velero install will also let you enable Rustic support, which installs the Rustic daemon set. I won't dive too deep into that because that's a longer topic, but the Rustic daemon set will put Rustic on each node. Yeah, that's the install command. We also have a Helm chart for installing Velero that has all the same options.
Awesome. Well, I appreciate that rundown from y'all. I wanted to mention, while Carlisia and Nolan were speaking, I went ahead and created our class and claim, which led to the creation of this Cloud SQL instance object, which is a managed resource, so representing a Cloud SQL instance on GCP. You can see that our state is currently pending create, so that's being provisioned as we speak. And if we look for the Postgres instance here, we should see that it's here, and it is referencing our class, which then led it to be able to create the actual managed resource, which led to the creation of a Cloud SQL instance on GCP. When that becomes ready, both the Cloud SQL instance and the claim here, the Postgres instance claim, will become bound. And we'll also see the connection secret present in our default namespace here where we created the claim. Once again, those managed resources are at the cluster scope, and our claims live at the namespace scope. So you consume those claims in the namespace that you create them. So while that is coming up, I want to go back to Nolan and give him an opportunity to talk about how persistent volumes are snapshotted in Velero, since we aren't going to talk about that too much today in the demos. While Nolan's speaking, I want to point out a couple of the next steps that are going to happen here. So let me see if I can pull this up. So once this becomes provisioned and our Cloud SQL instance is ready to be consumed, I am going to go ahead and create a backup of it. So if we look at Velero backup create, these are the commands I'm going to run here. I'm then going to delete the kind cluster and then recreate a kind cluster, install Velero again, and then run a restore with that backup, which it'll know about that backup because, as we mentioned before, that sync controller is going to make it aware of that in our cluster. So while I'm waiting for the infrastructure to provision, Nolan, do you just kind of want to take it away and talk about those volume snapshots a little bit?
Yeah, so volume snapshots in Velero started with the cloud providers, the big three public cloud providers in the West, at least, Amazon, Google, and Azure. So Velero uses snapshots by using the volume snapshot APIs of each of those providers. When it encounters a PV, it will get the volume ID off the PV and pass that into, trying to remember the API, but the volume snapshotter plugin will take, I can't remember, it's the PV itself or the volume ID, but it will take one of those and issue a request to the storage platform's API and say, give me a snapshot. Once it gets to the snapshot ID, it will send that back to Velero Core, which will store that So this is actually asynchronous from Valero's point of view. We say just get the ID and move on, letting the storage system do all of that work. And inside the Velero backup that's in object store, we just keep basically a list of those snapshot IDs. So we have those in object storage so we can refer back to them when we need to go restore. Our current limitation is that those have to be in the same region or availability zone, depending on your storage platform. And the other thing we're working on, especially with here at VMware, is how do we make this work on on-premise environments? Because on the cloud providers, it's easy to hand wave away like stuff like replicate that snapshot off the local node, but that's much harder when you're dealing with an on-premise cluster. So that's one of the things that's coming in Velero. We're talking about this because it's a big design change, and it's also something that we have to kind of change with CSI, which works differently from our Velero native plugins, which CSI and Velero native plugin support are going to exist side by side for the foreseeable future, just because not everyone's going to change. CSI, by the way, is a container storage interface. For those who are not familiar, it's a way for storage vendors to write drivers for their storage platform that is agnostic to whatever container orchestrator you're using. So you don't have to have a different driver for Kubernetes and Mesos and whatever else, Docker Swarm. And for Velero, it'd be great if we could use the CSI snapshotting APIs. So you as the storage vendor and you as the user don't have to go out and get a separate plugin for Velero. So the goal, the dream, is to just use their provided drivers and let Velero consume those.
Definitely. Yeah.
So that's a very whirlwind explanation.
Yeah, well, the main idea there about that extensibility is huge, right? Being able to kind of standardize on that interface opens up a lot of different possibilities, both for now and in the future. So I can really see how that's going to add a lot of value to the project. So kind of catching folks up with what we've been doing in the demo here, while Nolan was giving that rundown, is you can see that our Cloud SQL instance became runnable and then was bound to the claim. We then took a snapshot of the current state of the cluster. So I didn't customize this at all. It was just the using the CLI tool, doing the Velero backup create, and I named it TBS 16 since this is episode 16. And then after that, I just went ahead and deleted the kind cluster. So did not delete any resources. So right now, those resources, the Cloud SQL instance, still exists on GCP. And now that I've created another kind cluster, I can once again install Velero. So this is a completely empty cluster right now. And when I install Velero, we'll see that with that backup sync, we're going to have access to the backup that I created before I destroyed the cluster. And then we'll be able to restore it into this new cluster. Something that's important to note here about why this is a bit more complex than just recreating resources is the ownership between different types of resources in the Crossplane ecosystem is really important, both from that class claim perspective, but also for connection secrets, as well as the providers that we install. So when you install a provider with Crossplane into a Kubernetes cluster, it's going to bring along CRDs, those custom GCP types that we saw, and it's going to have ownership on those. So basically, while that provider is installed, we want those CRD types to exist in the cluster. But if it's uninstalled, we want to clean those up for folks. But we have to be able to establish when that controller gets reinstalled and the CRDs get put back in place, who has ownership of those. And we have some different CRDs behind the scenes, which talk about what a provider or any other package that we'll look at later on owns and what it shares with others. So if we look at the cluster right now, it's just the Kubernetes system pods running as well as Velero. Let's go ahead and see if Velero was able to see our backup that we created. So those are going to be in the Velero namespace here. And you'll see we have this TBS 16 backup present. So what we want to see is that all of our controllers come back up and running. Our CRDs are present in the cluster. And then instances of those CRDs are established and have the right ownership model between them. And they're now managing that external infrastructure again. So if I run this backup, let's see what happens. All right, so it looks like our restore request was made. So we can now view that restore using this Velero restore describe command. It will take a moment for it to get those and sort out how they should be reinstalled into the cluster. But we should see things coming up shortly. Let's take a look at see if any of our controllers are present. So not yet. That restore is still in progress. One thing that I have a question at for Carlisia and Nolan is when you're reinstalling things, sometimes ordering is important. Generally with Kubernetes, the idea is that you're eventually consistent, right? So you should be able to create things and the controllers should know how to interact to associate them correctly and reconcile them and that sort of thing. Do you do any kind of advanced ordering and opinionated ordering when you're restoring objects into a cluster?
Yeah, yes. And I'm going to let Nolan answer that. And I'm going to take the tiny break opportunity to say goodbye. So I don't interrupt again later. It was such a pleasure. I do have a hard stop at 10. This was really good and fun. And I'm really glad, Dan, that you asked us to be on the show. And hopefully it will help people understand better what happens behind the scene with Crossplane as you use Valero for backups.
Absolutely. And Carlisia, we really appreciate you coming on and appreciate all the work you do in the community, especially how you produce things for folks that are newer and really welcome people in. So thanks for joining and I hope to have you on the show again in the future.
Yeah, thanks again. Bye.
Bye.
Bye, Carlisia.
Bye, Nolan.
So with restored ordering, we do have an explicit ordering. There's a well, it's not hard coded, but there is a default list in our server. And there's also on the Valero server, you can specify a list that you would like. And then there's a little bit of an escape hatch with the plugins. So the restore item action plugins can actually, when they return additional items, those get restored then and there. So, gotcha. So if say, so right now the order is, I believe namespaces are the very first thing, and then CRDs, or it might be CRDs and then namespaces. Then if those would kick off an item action, restore item action plugin, and those returned your custom thing, that custom thing would get restored right away. So we do have explicit ordering that helps there.
Definitely. I was kind of wondering about that because it was just kind of like working magically for me. And I was thinking that you'd probably be installing namespaces and CRDs before other things. But I wasn't sure because you could always take the approach of kind of like just keep attempting to doing things even if they were failing. So if the namespace wasn't present, you could keep trying. What was the decision like to go with that priority order rather than just trying over and over again?
So we actually do that in some places. We do that with CRDs themselves. So CRDs have like this, like accepting names. There's a couple conditions that CRDs have that you have to like have these two or three conditions that CRDs get into before they can actually create CRs. So like for certain resources, we do actually do that. So like namespaces, we check, and PVs, we check. And so for certain resources, yes, we actually do say, are they ready? Are they ready? Are they ready? Okay. The explicit ordering came from a need to say, hey, we need a PV before we can create a PVC to create the pod to reconstitute things. So in theory, Kubernetes should be able to create all the stuff and then reconcile. But on restore, it turns out there is some ordering. So Velero is a little weird in that Kubernetes doesn't care about ordering except for when it does. So those priorities actually came out of necessity, really, finding that stuff didn't work unless we stitched it together correctly. So I can give some examples of where like we know Velero doesn't work. So Helm 2 and Tiller, for example, if you have a Helm 2 workload, so if you take Velero, if let's say you take a whole cluster backup with Velero and it's running Helm 2 workloads, you restore it, you restore the whole thing, and then you say Helm get releases, and it will say there's none found, even though you restored all the stuff and the config maps are there. It's because it put the config maps there before it restored the pods. And the pods, Tiller doesn't know to look for pods on, to look for config maps on startup. If you put the Tiller pod there first, then restore the config maps that represented the release, it works. Gotcha. So there's times, and this is something we've been seeing with other teams of VMware experimenting with stuff. The operators or controllers don't know how to work when they've been restored.
Right.
They assume everything, like they assume everything's going to work the way their installer is going to work. So Velero does kind of break some of those assumptions sometimes. Helm 3, I think, is a little bit better. I actually have an issue on my plate to test that more thoroughly, but yeah, so going back to the original question, the priority ordering came from testing and finding, hey, it wouldn't work unless we did it this way.
Definitely. Yeah. And that's an interesting thing you bring up, that some controllers are not really knowledgeable of the situation they're getting installed into, and they always assume this priority ordering. That's one of the things that we had to address with our provider plugins, that, you know, if CRDs are already present for them when they try and install their CRDs, that, you know, that's okay. Or if, you know, they start running without the CRDs present, or if we try and actually restore the deployment that runs the controller, and then we create a cluster stack install, which is our unit for installing new providers, that it'll just say, oh, this has already been installed, I don't need to take any action here. So we made some of those adjustments as well to kind of fit that pattern. And it also just in general, outside of even backup and restore, it allows you to just have a more robust controller that can react to more scenarios.
Yeah, so, I think building it that way, like you said, it's more robust. It's to use the buzzword, it's more cloud native. But not every application is like that right now. So yeah.
Yeah, absolutely. So I wanted to point out that all of these resources did come back as expected. So if we look at our pods, we'll see Crossplane, the Crossplane Stack Manager are running, as well as the provider GCP controller. If we look at our CRDs that are present, which you can already see because I looked at instances of them, but let's see and make sure that the GCP ones are present here. So that looks good. And also for folks that haven't used the new version of Crossplane, all the providers now support just getting all the resources that exist for that provider by their key name. So GCP, AWS, Azure, so you can just get GCP. And we'll see here that our class was reinstalled, as well as our Cloud SQL instance, and it immediately picked up that external resource, and it is bound and runnable. So our claim should also be bound and runnable. So let's make sure that that is the case. So it is, and it's bound to that managed resource. And then we also should see that we have the connection secret present in our namespace, which we do, this con connection secret here. And it has all the data to be able to connect to a Cloud SQL instance. And so we're pretty much good to go. So this is a pretty simple example of just a single resource. It can get a lot more complex when you have resources that depend on each other. Nolan, I know we've gotten already a bit over time here. I wanted to check in with what kind of time you had. If you want to go into the more complex demo, we can, but also understand if you need to jump off here pretty soon.
I can probably finish out this demo, and then that's probably about all I've got.
Gotcha. Awesome. Well, we'll definitely respect that time. So this demo is pretty much wrapped up here. The other one does take some time, so we'll postpone that to another day. But essentially, what we would do in the other demo is use some of our stacks and apps, which stacks are basically bundles of resources that install a controller and reconcile them as a unit. And then apps allow you to deploy apps with a single CRD themselves. So we would install those controllers and CRDs. And then we create instances, for instance, a WordPress instance here, see those come up and you'd be able to interact with them. And then we'd once again go and destroy the cluster itself after taking a backup. And that continues to run while we are in, while we don't actually have the control plane running. So while the cluster is deleted and we're creating a new one, because those resources are running externally. And then once we reestablish control, we'll begin managing them with Crossplane as you would expect. So I might put together a little video for folks to try this. Also, per usual, the guide and the manifest will be available in the Crossplane/TBS repo. So we'll definitely point you to that. I think that pretty much wraps up most of the stuff we wanted to show today. Nolan, I wanted to give you an opportunity here at the end if there's anything else you wanted to touch on before we wrap up.
Well, we've got the Velero 1.4 beta coming soon. Like I said, I was hoping it would be Friday, but it's probably not going to be Friday. So hopefully next week at this point, but we will see. We're also open to contributors, whether that be reporting bugs, making comments, coming out. We've got the Valero Slack channel in the upstream Kubernetes Slack. We have a community meeting every Tuesday at noon Eastern or 9 a.m. Pacific time. And you can find more information at velero.io/community if you want to find out more about how to get involved. And yeah, thanks for having me on and showing this integration. It's always cool to see how people are using Velero and interacting with their stuff.
Yeah, absolutely. Well, we really appreciate it. And I'll make sure to continue to track some of that work that's being done with CSI. I'm excited to see that come through. And maybe we'll have you on for another show later down the line and show some more awesome examples of using newer features of Velero. So thanks for joining today, Nolan. To everyone in the chat, we appreciate you joining. It looks like we've had a few new folks join since we got started. So Rahul and Ashish, who I believe is also a maintainer possibly on the Velero project. And yep, Jared says, thanks for teaching us about Velero today. So thanks everyone for joining. We'll follow up with links to the demos that we ran through today. And Nolan, I hope you have a great rest of your day.
Great, thanks, you too.